This is 4.1 part 2, and we're just going to finish up the question that we were working on. So what was the square root of 0.81? Well, it's a square root, and 81 works well on our list, so it's going to be a good answer. The square root of 81 is 9, and for square roots, if there's an even number of decimals inside here, when the answer comes out, you cut the number of decimals in half. Now likewise, the same pattern continues for cube roots. Take a look at this number here at the end, 27. Go back to your very first page of cube roots. Cube roots is this list here. Is 27 on the right side of the equal sign on our list? Yes, which means that the cube root of 27 will be 3. So the cube root of this should work out fine if there's the right number of decimals. And the way it works for cube roots is you want the number of numbers after the decimal inside here to be a multiple of 3. So either 3 decimals or 6 or 9 or 12 will work. Other numbers in between there won't. So how is that going to work? The cube root of 27 is going to be 3. Let's count how many numbers there are after the decimal. There's the 0, which is 1, the 2, which is 2, and the 7, which is 3. So 1, 2, 3. To figure out how many decimals our answer has, you take 3 decimals afterwards and you divide it by the index, which is 3. 3 divided by 3 is 1, which means there's going to be 1 decimal here. Now this is a little tricky, and it's not the most important thing that I need you to know from this chapter, or for this section in particular. But it's good to know that there's patterns in math that occur, and you can use this same pattern to predict 4th roots and 5th roots. And it's just an interesting thing to know, and if you're understanding it, that's great. If it's a little confusing to you, don't let it cause you too much stress, because we'll work it out. So I've kind of explained in this series of steps what I've just talked about right now, but let's do a few more down here. Now, this one here is a square root. So look in your first column of your first page and see if 49 occurs there. 49 does occur there. Now the next thing we need to check is for square roots, we need the number of decimals to be divisible by 2. So 2 or 4 or 6 or 8. We have 1, 2, 3, 4. So that works out well. How do we do this then? What's the square root of 49? 7. How many decimal places do we have inside? 1, 2, 3, 4. Divide that by the 2. That's really there for a square root. 4 divided by 2 is 2. That means that our answer has to have 2 decimals. Right now the decimal is here, so we move it once, twice, which means 0.07 is my answer. Now for this next one, it's a cube root. Is 216 on our cube root list? And it is. For cube roots, we need the number of decimals inside the root to be divisible by 3. So 3, 6, 9, 12. We have 1, 2, 3, 4, 5, 6. So we're good. Now what's the cube root of 216? Let's look at our list. 216 is in our cube roots. It's right here. So the cube root of 216 will be 6. So the cube root of 216 is 6. And we take our number of decimals inside here, which is 6, divided by 3, which is 2. Our answer has to have 2 decimals. It has 1 now, so I add a 0 so that I can have 2. Now this next one, again, I like to think of cube roots as, or fractions with roots as having a numerator and a denominator. So I'm going to have a cube root of 0.008 on the top and a cube root of 0.125 excuse me, on the bottom. Is 8 on my cube root list? It certainly is. And I have 3 decimals inside there.